Okay, we're going to move on with regression analysis. There's lots of little bits and pieces, but as you're going to see when we go through an actual example, Excel's going to do it for you. But just to be able, you understand what Excel's doing and all the different parts and pieces. So this is simple linear regression, which is the first part of regression. Talks about a correlation exists between two data sets when the value of one is associated with the value of other in some way. So that's what we're looking for, is there's something going on between these two variables, right, that one is associated with the other. As one rises, the other rises. As one rises, the other falls, and so on. We're going to be looking at linear correlations, meaning that when you plot the data, it looks linear. It looks close to, we can see a pattern that can be approximated by a straight line. And so this paired data is paired like you're used to XY, okay, XY data. And again, we're looking for a relationship between these variables. There can be different types of data, the cross-sectional, such as the more you advertise, does your sales tend to go up? Or time series, where you can look at something like sales over time. The variables that we talk about, the X and the Y, typically the X, we use the same horizontal, and then the Y vertical. The X being your independent or explanatory variable, and then the Y being the dependent or the response variable. So we're looking at is the response variable changing? Does it respond to changes as the independent variable is changing? One way we can measure actually a linear correlation is with the linear correlation coefficient. This is a number between -1 and 1. The numbers don't mean if it's negative that it's bad and 1 that it's good. In fact, -1 is a very strong negative correlation, and a +1 is a very strong positive correlation. So we're actually looking at this correlation coefficient. Is there something happening? Okay, and as you can see down here, the closer you are to +1 or -1, then we definitely can see something is going on, a relationship with our data. And so we like to look at scatter plots because that's very quick and easy, especially in Excel, a couple of clicks of the mouse to visualize this relationship. So as you can see here, it does look like as X, as you go to the right, okay, as X gets larger, increases, it looks like Y is increasing. So there's definitely something going on, a linear, and that's close to 1. So a positive correlation. Negative correlation just says now as X gets larger, Y is actually going down. So you could think of something like, in fact, this would be a good one, of the more you advertise, the more your sales go up. This could be the more you exercise, your weight goes down. So we definitely have positive and negative correlations depending on what our data is doing. And then we get into looking at the coefficient of determination, which talks about what part of the change in Y, our dependent variable, can be attributed to the change in our independent variable, X. And of course, as you can imagine, if this is a portion, the closer to 1 is going to be better. This is the same R as our linear correlation coefficient. We're just squaring it. So that makes our -1 and our 1 from our linear correlations going to be a +1. And so it's a value between 0 and 1. Then once we figure out, we see a relationship between our data, we like to come up with a regression equation. So we've plotted all these data values and we find the best fit line, right? So all you're doing is looking at what is the equation of this line. If we're looking at population, we have this uppercase beta, b sub 0, for the intercept, for the slope, b sub 1, and then we could find an equation by taking the intercept plus the slope times our independent variable, and then plus some error. There's going to be some error. If we're actually dealing with a sample, which is what we're going to do, is we can calculate the y-intercept and we can calculate the slope with these big old bad formulas. Now, this is just showing you that there's different ways that you can calculate these. As you can see, summing all the y values, I mean, you can tell that's an average, right? And then summing all the x values, and both of these dividing by their sample size. We're going to have Excel do this for us, but it's interesting to actually look at the actual formulas to see how these are being computed. And then finally, we want to be able to test the slope, not the slop, sorry about that, of the regression line. So we want to know, and this is important because if our null hypothesis says that the slope, remember that was back here, b sub 1, our parameter, beta, if the slope equals 0, then think of what a zero slope is. It's a horizontal line, right? So that's saying when x increases, y is not doing anything. It's not changing at all. So there's no relationship between the two variables. So we want to be able to test that as well to see if there is an actual relationship. And that's what we're going to do in this section. I will have an example next for you to go through and show how to use Excel.